welcome back to my channel. In this video, we'll have a case study and answer the following questions that are given below. So let's get started. Automated analysis and classification of legal complaint using text mining and machine learning. Objective. Our objective is to develop a robust and autonomous system for analyzing, classifying, and categorizing legal complaints into a relevant category or section using text mining and machine learning techniques. Key goal. First, analyze unstructured data. Extract key information, for example, type of crime, location, date, from the complaint text. Use techniques like name entity recognition, NER, tokenization, and part of speech tagging to process and structure the unstructured text. Second, automate complaint classification. Train a supervised machine learning model to classify complaint into predefined categories based on historical labeled data. Implement enclave pre-processing techniques such as stop word removal, streaming, and feature extraction. Third, legal classification of complaint. Map exact feature to the most appropriate legal sections. Automate legal categorization through various algorithms like naive-Bayes, logistic regression, or support vector machine SVM. Fourth, utilize data structure and algorithm. Represent textual data using vector or embedded for efficient model training. Apply NPL algorithm for feature extraction and classification tasks. Fifth, evaluating performance. Use performance metrics such as accuracy, precision, recall, FN store, and confusion metrics to validate the classification system. For example, we have a complaint such as a theft of a mobile phone by an unknown person at MG Road on 2023 February 20. The phone was stolen while shopping in a store. The theft was wearing a black jacket and had a scar on his face. What will be the process to extract entities like theft, mobile phone, MG Road, and 2023 classified under IPC section 378 theft with relevant contextual information for legal references? Scope. The project aims to provide a scalable, accurate system to assist law enforcement agencies, legal profession, and organize in making analyzing large volume of complaint data effectively. The system should handle writes, text input, and provide actionable insight while ensuring compliance with legal and ethical standards. So here, we're going to start with question. The first question is, with reference to the life cycle of the data science project coming from the following table of a life cycle of data. In this, we'll have different stages. We have to write what are the objective, what are the key details of the stage, and what all the tools and library which are needed to solve the stage. So the first stage is define the problem. It is very clear that clearly define the business or research of the problem. In the next section, we will have what are the goals, what metrics will measure the success, identify constraint, and requirement. These generally do not use any tools. Second, data collection. Gather raw data relevant to the problem. Sources would be database, API, web scraping, sensors, surveys, third-party provider. References would be incomplete unstructured or biased data. We can use SQL, Python request beautiful so. Third, data exploration and pre-processing. Understand, clean, and prepare the data. Handling missing data, removing outlines, normalization, perform EDA with visualization and statistics to uncover pattern. We can use Panda, NumPy, Matplotlib, and Seaborn for this. Next is feature engineering. Its objective is to create a meaningful feature from a raw data to improve model. It may include transformations, feature selections, and generate new features. We can use skitlearn and feature tool for this. Next is model selection and building. The main objective is to choose or train a suitable machine learning or statistical model. In this, we will select a model, for example linear regression, random forest, or neural network. Split data into training, validation, and then test the sets. Skitlearn, TensorFlow. Sixth, model evaluation. Assess the model performance using validation and test data. Metrics such as MAE, RMAC, accuracy, precision, recall, and FN score. Use cross-validation to compare the result. For this, we can use skitlearn state models. Next is model deployment. It integrates the model into production system for real-world use. We may deploy via API, web application, or batch pipelines, ensuring scalability and reliability. Flask, Docker, AWS are the tools which can be used for model deployment. Next is monitoring and maintenance. It ensures the model remain accurate and relevant. Monitor performance, for example, drift detection. Update the model with the new data if necessary, debug and fix the issue. For this, we can use MLflow. The next is communication with reporting. It shares insight and findings with the stakeholder. Visualize results using dashboards, reports, presenting findings in the understandable format. For this, we may use Tableau, Power BI, Jupyter BI, Notebook, etc. Now, the next question is, consider the modeling design and development of the text mining based upon automatic relevance readdressal system. The objective is to classify agreements into predefined legal categories under IPC or BNS. This system take advantage from applying text mining data science techniques to automate complaints, classifying, enhance efficiency, and ensure consistency and accurate result. By streamlining the classification process, the system aims to assist legal profession and user in handling large volume of content effectively. Key operation of proposed designs include: first, explain how unstructured data is transformed into format suitable for machine learning models. Second, summarize the importance of legal classification in the context of grievance rehearsal. How TF-IDF or word embedding can be used to extract features from complaint text. Apply a simple classification algorithm to categorize the given grievance. So the answer starts with first analyzing the unstructured data. Unstructured data, such as text data from the written complaint, is a challenging analysis because it lacks predefined structure, like spreadsheet or any database. In data science, unstructured data can be processed and analyzed using text mining and natural language processing techniques. An example of text mining activity to analyze unstructured data would be semantic analysis or topic modeling. For instance, in the context of complaint, text mining would be applied to extract key information from a crime such as date, location, description of the incident. Techniques like tokenization, parts of speech tagging, name entity recognition, and classification can be used to break down and categorize the complaint data into relevant components for further analysis. For example, if the complaint contains phrases like stolen phone and MG road, text mining can identify entities, for example, mobile phone and MG road, and classify a complaint under the theft category. Second will be automating classification. Text mining techniques can automate the classification of the written complaint using machine learning and natural language process. By training a model on a labeled dataset of a complaint, the model learns to classify new unseen complaint into predefined categories. The process generally involves the following steps. First, text preprocessing. It converts the text into structured format, including tokenization, removing stop words, streamlining, and lemmatization. Feature extraction. Extract meaningful features such as term frequency, inverse document frequency, or word embedding. Model training. Use supervised machine learning algorithms like support vector machines, SVM, naive Bayes, random forest to train classifiers. Model evaluation. Evaluate the classifier performance using metrics like accuracy, precision, recall, and FN score. Technologies like NLTK, Natural Language Toolkit, Spike, and TensorFlow are commonly used for text mining and complaint classification. Third, legal classification of complaint. The approach to identify the appropriate IPCVNN section involves several steps. First, text preprocessing. First, we will pre-process the text by removing unnecessary words and extract the relevant tools, keywords like theft, mobile phone, MG road, and the date. Name entity recognition. Identify entities such as location, MG road, and date. Text classification. Using a trained machine learning model, classify a complaint into categories such as theft. The IPC section 378 might be applicable. Algorithm selection. Algorithms such as decision tree, support vector machines, or naive Bayes can be applied to predict legal section based on the text. Based on the complaint, IPC section 375 is likely applicable as it relates to the unlawful taking of another person's property. Now the fourth question, data structure and an algorithm for the legal classification. The task of classifying complaint into IPC or BNS section requires suitable data structure and algorithm to process and classify the text data. Data structure will be used as text representation. Text representation can be used in data structures like term frequency, inverse document frequency, vectors, or word embedded building. This structure converts raw data into numerical vectors that machine algorithm can process. Feature matrix. A matrix where each row represents a component and each column represents a feature. It is commonly used as input of machine learning algorithms. Algorithms used. Text classification algorithm. Supervised learning algorithms such as naive Bayes, support vector machines, and logistic regression can be used for classifying content into relevant categories. Natural language processing. Algorithms for tokenization, parts of speech tagging, and name entity recognition help in extracting information features like crime, type, and other entities. This algorithm will be help categorizing the content under appropriate IPC section by analyzing its content. Fifth, performance metrics for the text mining. The performance of the algorithm in text mining can be assessed using several key metrics. First, accuracy. Accuracy measures the overall correctness of the classifier by calculating the percent of correctly classified instance. Accuracy is equals to total positive plus total negative upon the text. Precision. The proportion of true positive result among all positive predictions indicate the reliability of the classifier. Recall. The proportion of true positive result among all actual positive showing how well the model captured the relevant data. F1 score. F1 score is a harmonic mean of precision and recall, used when you need to balance both metrics. Confusion matrix. A table used to evaluate the performance of classification model by displaying true positive, true negative, and false negative. This matrix allow to evaluate how well the text mining model classifies complaint into the correct IPC business section, ensuring the model effectiveness and accuracy.